All right, good morning. This video is on graphing quadratics. This is our last section on 8.5. And it's on using what's called as intercept form. So in the past, we worked on standard form. We've also worked on vertex form. Intercept form, the way I want you to think about this is, right, going back to our last chapter, is where we were to factor polynomials. If we have a factored polynomial, there's a way you can graph this. But let's go and look at this beginning part. Quadratics can be written in standard form, which is ax squared plus bx plus c. They can be written in vertex form, which is a times x minus h squared plus k. But they can also be written in intercept form. So this is f of x equal to, we have our a value, and then in two parentheses here, we're going to have x minus p and x minus q. And generally I write my q's with a little horizontal line through it. So it says in here, this worked example, the x-intercepts are p and q. And remembering this from vertex form, if you look at this, notice how I have a negative p and a negative q. So the way we want to think about this is what's ever here, we want to think of the opposite. Okay. Now, also, so when we look at that, that's where we're going to graph our x-intercept. So p is right here and q is right here. Now, since they are graphed like this on the x-axis, your axis of symmetry, this vertical line, right, we know that it goes through the vertex, but it should be equal distance between p and q. So as you see on the second bullet point, the axis of symmetry is halfway between p and q, or p comma 0 and q comma 0, so that the axis of symmetry is this. It's p plus q divided by 2. If you remember from our math 8 level class, when you add up values and then divide by the number of values, this is what's called as the average or the mean. Okay. Right, so the average of, let's say, 60 and 80%. Let's say you got 60% quarter 1, 80% quarter 2. If you add them up, right, it's 140 divided by 2, it's 70. And 70 is in the middle of 60 and 80. And then also, right, noticing our a value, nothing different. The graph opens up when the a value is greater than 0, it's positive. Opens down when a is less than 0, negative. Okay, so with this, there is some work to find our vertex. Not as much work as standard form, but a little bit more work than vertex form. So let's get to our first example. We're going to graph this function and then also determine the domain and range. So looking at this, right, we see, right, I want you to think again the opposite. And the reason it's the opposite, you don't have to write this next part, but we're using the zero product property. If we're trying to find the zeros of a function, that's like finding the x-intercept. So when you're trying to find the x-intercept, you set y equal to 0. F of x is 0, and then that's where we use the zero product property. So this part don't write, right? You would put x plus 1 equal to 0, solve there. X minus 5 equal to 0, solve there. You'd get that this is negative 1 and this is positive 5. But what we're doing here, we're just looking at what's inside of the parentheses or our product and setting the opposite. Okay, so since this is written in intercept form, a times x minus p and x minus q, off to the left, right, p is a value, is the opposite of positive 1, so it's negative 1. Q is the opposite of negative 5, so it's positive 5. So already with that, you could actually graph your x-intercepts, negative 1, positive 5. So negative 1's right here, positive 5's right here. So we know our vertex is somewhere in the middle. So if I count 1, 2, 3, 4, 5, 6, half of going 6 is 3. So you could count 3, 1, 2, 3. So right here, this is our axis of symmetry. But we're going to talk about how we can find the axis of symmetry. Okay, even though I'm going to keep that axis of symmetry there. This is crossing the x-axis at 2. So this is x equal to positive 2. So how do we find it? Right, we're going to take x equal to p plus q divided by 2. So p is negative 1, q is positive 5. So if we add them, divided by 2. And we're adding, but we have different signs, so we're technically subtracting. Negative 1 plus 5 is 4. 4 divided by 2 is 2. So that's our axis of symmetry. Right here. And that's what we have here. X equal to positive 2. Okay. Sometimes we'll get fractions, sometimes we'll get decimals, but this one's a whole number, so it worked out. Now, we remember that in standard form, once you find your axis of symmetry, the x value of your vertex, right? If I'm going to write it maybe down here, our vertex is going to be 2 comma something else. To find that something else, you plug the x value into f of x. So I'm going to take that original function. We're going to, instead of putting f of x, we're going to put f of 2. But actually, you know what? I'm gonna write the entire function, but I'm gonna skip the x though. So the first parentheses was x plus 1. I'm gonna put blank plus 1. The second, blank minus 5. Or sorry, x minus 5. I'll put blank minus 5. And I'm just gonna color code here. Right? If I put this in red, this will be f of 2 equal to negative. The first quantity is 2 plus 1 and 2 minus 5. We'll simplify each one. Right, this part is 2 plus 1 is 3. 2 minus 5 is negative 3. So if we write this function, this is, you can use the negative and this x here, or sorry, the 3. Negative and a 3, we'll just put negative 3. And I'm just going to keep this negative 3. So we're trying to figure out what's negative 3 times negative 3. It's a positive 9. So we have f of 2 equal to positive 9. So our vertex is 2 comma 9. Okay, so let's graph that. 2 comma 9, this is 2 to the right and 9 up. So that is right here. And we could use our a value times our odd number sequence, but we actually won't need it for this one, but we can write it on here. Right, our a value is a negative. You could think this is negative 1. So, right, multiplying all this by negative 1, this is negative 1, negative 3, negative 5. But actually, I'm going to draw my vertex, though. Or I'm going to draw the parabola. Just with these 3 points. Oops. Or it's not going to be the prettiest parabola, but something like that. But I want you to know that if we were to move like this, going 1 to the left, 1 down, 1 to the left, 3 down, 1 to the left, 5 down, yeah, you could probably get points that are more accurate here. 1 to the right, 1 down, 1 to the right, 3 down, 1 to the right, 5 down. But we can graph this using just our x-intercept and our vertex. Okay. But let's also put the domain and range. The domain of this, D is all real numbers. Again, the symbol for all real numbers is double-legged R, capital R. And the range of this is everything, we're going down, everything below a specific value. So it looks like we have a maximum vertex, everything below this red line. So, right, this red line is at a height of 9. So everything, y is less than or equal to, y is less than or equal to positive 9. Okay. All right, so moving on to the next one. Now this is incorporating, right, what we know. This isn't written in intercept form, but what we can do is we can factor this out. If you remember from factoring polynomials, we always look for a greatest common factor, a GCF. The greatest common factor here, we can factor out a 2. If I factor out a 2, 2x squared becomes 2 times x squared. Factor out a -8, a 2 from that, this is -4. And you remember these are two squares, so this is a difference of squares. This was on special products. Or if you look in your factoring, this can be factoring two terms. This is where we have x minus 2 and x plus 2. Okay, so we know from this, right, our p value and our q value is just the opposite of both of these numbers. So p, opposite of -2 is +2, and opposite of +2 is -2. So let's graph that on the x and y axis, 2 and -2. Or just the x-axis, sorry. Okay, and then now we're finding our vertex. So I'm going to take -2 plus +2 and also always divide by 2 since there's two values. -2 plus 2 is 0, and half of 0 is just 0. Okay, this is our axis of symmetry and is also the x part of our vertex. Okay, so let's draw a dashed line at x equal to 0. It's just exactly the y-axis. So it might be kind of hard to see, but I'm just putting a dashed line along the y-axis at x equal to 0. Okay, and at this point, we're now going to plug in 0 into our original function. Now you can also plug it into this, but I'm just going to take the original one. Okay, so instead of f of x, I'll put f of blank. Instead of 2x squared, I'll put 2 parentheses squared, and then I'll put -8. Now let's plug it into color code. I'm taking 0. Okay, and simplifying this. 0 squared, that means 0 times 0, that's 0. And then 2 times 0, right, that's still 0. So what we have is 0 minus 8, and that's just -8. So our final part of this function is f of 0 equal to -8. So let's put -8 here. This is our vertex. So 0, -8 is not moving at all left and right, just moving 8 down. Looks like it's right here. Okay. Connect it with our solutions. And let's go and write the domain range. I'll write it on the graph. The domain, again, all real numbers every single time. The range is everything that is, looks like we have a minimum vertex. Everything that's above that is our range. That is everything greater than or equal to. So y is greater than or equal to -8. Okay. All right, let's go to the back side. Now finding zeros of a function. So this is exactly what we've been doing, except we don't have to graph it. But just to more formally write out when you find your solutions. So it says find the zeros of f of x equal to x minus 1 times x plus 2. So it says find. So when it's asking this, it's saying find the x values for f of x is 0. So I'm just going to put a 0 around that. That means the entire function is 0. So we're going to have 0 equal to x minus 1 times x plus 2. And this is the zero product property. Right, if you remember from last chapter, that means either the first one, zero product property. Okay, I'm going to set the first thing equal to 0, x minus 1, and the second thing equal to 0, x plus 2. Right, if I add 1 to both sides, our answer here is x equal to 1. And here, if I subtract 2 to both sides, we'll have x equal to -2. Okay, so it doesn't ask us to find the vertex or anything like that. It's just finding the zeros. So what solutions, what values make the equation true? So we're going to say that these zeros for f of x are -2 and +1. Typically we just go in order from least to greatest. All right, and then we have 2 more examples. Example 4. So find the zeros of this. Now this is something you're going to have to factor. So if we write f of x, always when we factor something, we look at what's in common. Of -2x squared, -10x, and -12. We can factor out a 2. But generally, right, you want to keep that same sign. So it's going to be a -2. So if we factor that out from this, if you divide everything by -2, this will be x squared. The next term will be 5 squared, right? -10x divided, or sorry, -5x. -10x divided by -2 is a +5x. And -12 divided by -2 is a +6. And we can factor this. This may not seem like it, but you can use x factor. It's been a while. We take our middle value of 5, our b value, and our c value is 6. So what factors of 6, if you were to add them, equals 5? It's 2 and 3. So our final, well, not our final answer, but the final factored form, so f of x equal to -2. The first one will be x plus 2. Second part of our product is x plus 3. Okay. Now, we could set this up using the zero product property, but we know it's just going to be the opposite of these two values. So let's just write that. It says the zeros are -3 and -2. Just putting in order from least to greatest. All right, so now we're going to combine that idea and what we did on the front side to graph now. So this says use the zeros to graph this function. All right, so first we're going to factor. And we can use x factor because our a value is 1, so we're going to put -2 our b value and -3 our c value. And the factors that work out for this are 1 and -3. So rewriting this now in factored form using intercept form, this is f of x equal to, this will be x plus 1 and x minus 3. All right, now I'm just going to write it underneath. Our p value is the opposite of +1, so it's -1. And our q value is the opposite of -3, so it's +3. Let's graph that on the x-axis, so -1's right here. +3's right here. Since this is in standard form, if you remember from our last notes, for the y-intercept, we set x equal to 0. Right, this would be 0, this would be 0. The x-intercept is just this number right here. Or sorry, the y-intercept. So -3 on the y-axis. So you can even get more information. -3 on the y-axis is right here. I'll put this in a different color so we can just, so we know where that point's coming from. Anyways, so let's find our vertex. So our vertex here, right, x equal to p plus q divided by 2 will be -1 plus 3 divided by 2. This will be 2 over 2, which is 1. That's our axis of symmetry. And again, that's the beginning part of our vertex. So +1, where it crosses 1 on the x-axis. Okay, so now plugging this in, let me put parentheses in place of our x's. So instead of x squared, we're going to have parentheses squared. Minus 2x will be -2 times parentheses minus 3. We'll plug a 1 and simplify. Okay, 1 squared is 1. Negative 2 times 1 is negative 2, and then minus 3. This equals negative 1, and negative 1 minus 3 is negative 4. So our final answer for this function, f of 1 equal to negative 4. So let's put negative 4 for our y value of our vertex. 1, negative 4, that's 1 to the right and 4 down. And I know it's going to go through these x values, but since I already also identified our y-intercept, it's also going to go through that blue point. Okay, we'll draw that in. This doesn't tell us to find the domain and range, so we're done with that. As we're finished with our notes, good. I do want to give you 2 examples. We're not going to go through the entire examples, but I will go over how to find the vertex. So I'd like for you to take out some type of scratch paper. I'm going to go through these 2 examples. We're just going to find the vertex for each one. Let's go through the first one. But I'd like for you on your scratch paper to label an x and y axis, go 10 in each direction. So our p value for this one is negative 1. Q value is positive 2. So we're going to have negative 1 plus 2 divided by 2. Right, and if you set this up, this will be equal to 1. So we have 1/2. So you can get fractions, but I want to make sure that we're comfortable getting these fractions. So this is the x part of our vertex. So our vertex is going to be 1/2, comma, we'll find the y value. So let's plug in 1/2 into this. We'll have 5. Instead of x plus 1, it'll be 1/2 plus 1. And this will be 1/2 minus 2. Okay. Now with this, when you're adding a whole number with a fraction, you need common denominators. So we could put this over 1. A common denominator of 1 and 2 is 2. That's already 2, but you can multiply the second one by 2. So really this becomes 1/2 plus 2/2, which is 3/2. Right, same thing here. If we put this over 1, we need a common denominator, also 2. Let's multiply this by 2. Right, this is 1/2 minus, this will be 4/2. If you subtract that, 1 minus 4 is a negative 3, so negative 3/2. Oh, sorry, negative, this is supposed to be half. And when you multiply, right, we can multiply our fractions here. This would be, multiply our numerators separately from our denominators. We're going to get negative 9/4, but we also have times this 5. And you could put this over 1. So this would be 5 times negative 9 is negative 45. And 4. So we'll put negative 45/4. Now that might be kind of hard to, right, maybe estimate on a number line. Right, so for this, negative 45/4, let's put a calculator here. 45/4. All right, that's clear. 45 divided by 4. So that's 11 1/4. Right, so like under this, you could put like 11.25. Well, it's a negative. So you're going to go a half to the right and 11.25 down. So I'll leave that for you to graph. And then let's go to the second one as well. All right, so this one, p value is negative 4. Q value is negative 1. So negative 4 plus a negative 1 divided by 2. This will be negative 5/2. So our vertex will be negative 5/2. Now you can also convert this to a mixed number, like 2 can go into 5 twice with a remainder of 1 over 2. That's what we divided by. So if you can't graph 5/2, you can graph 2.5. But let's plug that 5/2 in here. So g of negative 5/2. So plus 4. and negative 5 halves plus 1. So common denominator, we're going to have to put this over 1. Common denominator is 2. So this will be still negative 5 halves, and this will be 8 halves. Negative 5 plus 8 is a positive 3. So 3 halves. All right, put this over 1. Common denominator of 2. This is negative 5 halves plus 2 halves. Different signs, we're subtracting. Negative 5 plus 2 is a negative 3 halves. And this is actually the same as the last one, where if we multiply, it's negative 9. We multiply 2 times 2 as 4. So negative 9 fourths. Again, that might be hard to graph, so figure out it's a mixed number. 4 can go into 9 twice. That's 8 with a remainder of 1. We divide it by 4, so that's negative 2 1/4. Or you can go right 2 1/2 left, 2 1/4 down to grab your vertex. So let's try to graph that. 2 1/2. Or this is 2 1/2 is somewhere here, and then 2 1/4 down. Maybe that's 1. Maybe that's 2. Just a little bit, somewhere right there. As long as you can estimate. Right, and put a point similar to where that region should be, you're good. All right, that's going to conclude this video. You can always email me if you have any questions. And you are welcome to now work on Prodigy.